This video is going to review the basics of how to make something called a motion map. A motion map is just a simple picture that shows what a moving object was doing by using a series of dots. So what you see here is a position scale so that I can measure where the object is located. And notice there's a paper clip here at the top. So on a motion map, what you do is you start by placing a dot at the initial position of the object, and you give it a number. And that the first dot is always given the number 0. What that means is when the timer was 0, this is where the object was located. Oh. So what I'm going to do now is I'm going to start moving the object forward. And as it moves, it's a lot like the mealworm lab. As it moves forward, I'm going to follow it and leave dots to show where it has been. So every second I leave a dot. Here he is. Dun, dun, dun. Here he is. Okay, so each of those dots, it's just like a trail of breadcrumbs to show where the object has been. So after 1 second, 2 seconds, and so on. Again, the numbers with the dot represent the time, and the black axis underneath represents the position. So I could say at time equals 2, position equals 4. And I can see that if I look at my number 2 dot lines up with position 4 on my scale. Now, we often draw arrows to show the motion of the object. So I'm going to connect these with an arrow. These arrows represent velocity. A very long arrow means that the object had a lot of velocity. We would use the word fast. And a very short arrow means that the object had very little velocity. We would use the word slow. Now, it is possible for the object to stop moving altogether. So let me show you how we would deal with that. I'm going to get out that paper clip again. And I'm going to start with my initial dot. Okay, I'm going to move him forward. So 1 second later, here he is. 2 seconds later, here he is. Oh no, he stops moving. 3 seconds later, I would draw another dot in the same position. Another second later, he's still there. And he finally decides to move again. So I continue following him as he crosses the screen. When I number the dots, notice that I have several dots that are stacked on top of each other. This doesn't mean that the paper clip slid up the screen. It's just my way of showing that he stayed at that position for several time intervals. Once again, we can connect the moving segments with arrows to show the motion of the object. It's very important that you number your dots because the object is not always moving in the forward direction and it doesn't always start at position 0. So for example, if I have a motion map like this, just looking at those dots, I don't know whether the object started at 2 and moved forward, or if it started at 6 and moved backwards. And I can clear that up easily by putting numbers to show that this particular object was moving in the negative direction. So again, motion maps, it's just a series of dots. The numbers tell you what time the dots occurred. The arrows show you the velocity. Long arrows are fast, short arrows are slow, and if the object stops moving, you can just stack the dots up the page to show that there's more than one time at the same position.